Now what we're going to do is we're going to find a relationship between radicals and exponents. So we just talked about our rules of exponents. We're going to find a relationship here. So find the value of each of the following. Square root of 3 times the square root of 3 is the square root of 3 times 3, which is 9, which is just 3. And then here, this is supposed to look like a 3 to the 1 half times a 3 to the 1 half. When we have something like this, we add the exponents. So this is 1 half plus 1 half, which is 3 to the first, which is just 3. So we notice that these two things right here are equal to the same thing, which means those things are equal to each other. So square root of 3 is the same thing as 3 to the 1 half. So the square root of 3 equals 3 to the 1 half. And so this demonstrates a property that we learn. And actually what we have here is when we have a fraction in the exponent, it's the same thing as having a radical. And this number is here, which it's not written there because whenever we have a square root, it's an understood 2. And then the 1 is actually the exponent either of 3, or you can put it on the outside here of the whole thing. So the property that we can look at, we can say that x to the a over b is equal to the bth root, so b, the denominator goes here, of x to the a, or another way of writing it is bx and then this whole thing to the a power. So either way, we use this one a little more often, but that's a property that we have of fractional exponents. We even say rational exponents. So we're going to go from radical to exponential form, and then later we're going to look at going from exponential form back to radical form. So the first thing we do is we factor the numbers into primes, and then write it in exponential form and simplify all fractions. So in this one, we have 5 x squared y. Well, all these are in primes already, so we don't really need to do anything. 5's a prime, we don't do anything with that. And so write in exponential form, well, this is 5 x squared y, and said it was the cubed root, so this is to the 1/3. And now we can think of this, we can use our properties of exponents, and this is 5 to the 1/3. So we multiply this times this, x to the 2/3, and y to the 1/3. And we don't need to, there's nothing to simplify here. All these fractions, none of those fractions reduce, so that's our answer. The next one here, we'll do the same idea, except this one, this 25, we can write as 5 squared. And we can put that in exponential form. So this is to the 1/3 power again, similar to our last example. So this is 5 squared x to the 6th y cubed to the 1/3 power, using that property we just learned. And now we're going to look at that product property, power of a product. And we get 5 to the 2/3, x to the 6/3, and y to the 3/3. Now some of these can be reduced. This 5 to the 2/3, we can't do anything with that, so we're going to leave it as 5 to the 2/3. But 6 over 3 is 2, so we just have x squared. And 3 over 3 is 1, so y to the first, or just y. And that's how we simplify those. Moving on to some other ones. 64. Factor the number into primes. So 64 is 8 times 8. And hopefully most of you know that 8 is 2 times 2 times 2. And so 64 is 2 to the 6th. So we have a 4th root here, 2 to the 6th, x to the 5th, and y cubed. We're going to write that as an exponential. So we have 2 to the 6th, x to the 5th, y cubed, the whole thing to the 1/4 power. And this gives us 2 to the 6/4, x to the 5/4, and y to the 3/4. And notice this one can reduce, so it's 2 to the 3/2, x to the 5/4, and then y to the 3/4. We'll actually learn a little bit more about this in a later lesson, simplifying these things. Next one. Now I'm going to look at this one a little bit differently. I'm still going to do my prime. 16, if you think through that, you could make a factor tree, but that is 2 to the 4th. So we're writing it as primes. And what I'm going to do here, I'm just going, instead of going one step, two step, like we wrote it as the whole thing to the 1/4 and then use this 1/4 with each of the exponents, I'm going to go ahead and right away and realize this is a 1/3. So this is going to be 2 to the 4/3, a to the 3/3, b to the 2/3, and c to the 5/3. And we want to see if any of those simplify. Well, the 3/3 does, so we'll have 2 to the 4/3. 3/3 is just 1, so this is an a, b to the 2/3, c to the 5/3. And we changed it from exponential form into, we changed it from radical form into exponential form. Now what we want to do is we want to look at going back the other way. So maybe starting with something like this and figuring out what is that as a radical. So what we're going to do here is we're going to make sure we have a common denominator. And once we have a common denominator, we can write it in radical form with the denominator as the root and the numerator as the power of each factor. These are already common denominators, which means we want a 4th root. So the common denominator goes out here, and then we have 2, and we have the numerator with this, so 2 cubed, and a to the 1st, which we can just put a, and that's writing it as a radical. This one, it's the same idea, but there is an extra step because these are not all common denominators, so we need to make them common denominators. So for this one, we would multiply this by a 2/2, because our common denominator is 6, and so that's 4/6. And this one we can think of, we could multiply by 3/3, which is 3/6. And so our common denominator, so we'll kind of cross this out. This 4/6 goes with this, and this is a 3/6. So our common denominator is 6. And then we're going to have each term here with its numerator as the exponent. So 7 squared, x to the 4th, and y to the 3rd. And we can, since we know what 7 squared is, we can put 49 here. If it ends up being too large of a number, like 7 to the 5th, we wouldn't multiply that out. We could just leave it as 7 to the 5th. And so there's our answer. Either one would be fine. I would accept this also with the 7 squared. Next one, same idea. We need a common denominator. In this one, the common denominator would be 4. So let's write that with denominators of 4. So 3 to the 1/2 is the same as 3 to the 2/4, because we want a denominator of 4. This one already is 4. This is to the 3/4. And then y to the, and we can multiply this by 2/2 and realize that's to the 6/4. Now we can put all of those in a radical. Our denominators are 4, so that is the index here. And then we have a 3 squared. Well, what's 3 squared? That's 9. We have x cubed and y to the 6th. Our next one, we could get a common denominator for all 3 of these, but this is simplified as much as possible. We don't need to put that as a radical, so we can leave that as a squared. So we're going to leave that as is. And the other 2 we'll work with. So out of the 3/10 and the 2/5, a common denominator is 10. So we can multiply this one by 2/2, which would give us 4/10. And so this a squared doesn't need to be under a radical because it's not a fraction, so we'll leave that on the outside. And then we'll have our root, and this is a 3/10, and this is going to be a 4/10. So our root is 10, 10th root, and then we'll have a 5 cubed, which if you want to multiply that out, 5 cubed is 125, and b to the 4th. And so if something's not in a fraction already, you don't need to put that as a fraction. So a squared times the 10th root of 5 cubed, which if you want to put as 125, that's fine, b to the 4th. This is just a review of the exponential rules that we had earlier. And it'll just take a minute to work through these. So this is the same base, and what do we do with powers if they have the same base? Well, we're going to add these. So this is a 2 to the 3 halves plus 1 half is 4 halves. Well, 4 halves is 2, so this is a 2 squared, which is really just 4. This next one is very simple if you remember the rule. We can look in here and look, but this is just some number to the 0 power, and anything to the 0 power is 1. We have division here, and when we have division with exponents, they're the same base, so we can subtract the exponents. So this is really just 2 to the 3 halves minus 1 half. We're subtracting the exponents. Well, that's 3 halves minus 2 halves is 3 halves minus 1 half is 2 halves, which is really just 2 to the first, which 2 to the first is just 2. When we have a power raised to a power, we multiply. I'll show the work here, but some of you can probably do this pretty quickly. 3/4 times 4, which we can think of as times 4 over 1. These are going to simplify, and we have 3 cubed. And since that's a smaller number we can work with, we can just say 3 cubed. We know is 3 times 3 times 3, which is 27. And this last one deals with negative exponents. If we have a negative exponent, we can think of this as over 1. The negative exponent's in the numerator. We can move it to the denominator and drop the negative. And then, since this is like a 1 times 6 to the negative 2, we have a 1 still in the numerator. And we have 1 over 6 squared, which is 1 over 36. And so you should be able to, from this lesson, change from radical form to exponential form and vice versa, and make sure you know your rules of exponents, because we're going to be using those throughout, and knowing those very well will help things go more fluently.